So here, this is the thing we are going to do. So we have a crank that rotates OA with an angular velocity of 12. So 12 meaning is plus 12, right? Which is counterclockwise, okay? Then we have to find the velocity of piston B, this guy. Okay, the velocity of piston B. Exactly, I couldn't find exactly same. Let me see what I have here. Okay, I couldn't find exactly this kind of what do you call it? Groove? What do you call it? So I couldn't find the vertical piston. Okay, that's why I have the horizontal piston here. So I want to ask you a question here. This guy from here to here, see the brown thing, right? So when the brown is on the upper half, what is the motion of this piston, this guy? Towards left or right?
Left.
Upper half, the motion is left. Lower half, motion is?
Right.
Right. So do you see that, right? So that's very important, okay? In the same way, what might happen here? Upper half, so upper half, the motion will be up, okay? Upper half motion will be up and lower half motion will be down. Do you agree? Here too. Okay, in the case, in this kind of piston. So that's what happens. Now, AB, rod AB is in upper half, right? Meaning, what is the motion of this guy? Up or down?
Up. Up.
Up, right? So this is towards up. So this is the motion of this guy. Let me call this is BB. Okay, this is BB. Now, okay, now we have to find the velocity of piston B. We need to find BB now. And the angular velocity of rod AB. And also we have to find the omega AB, okay? Omega AB. This looks like W. Let me make omega like that. Angular velocity of rod AB, omega AB, and BB. Okay? Given that this guy rotates in 12 radian per second. Okay? First of all, let's figure out this rotation, okay? Figure out this rotation first. Meaning, let's talk about the rotation of this green thing here. Remember this green thing? So what is the rotation of the green thing? This is the circle of the green thing, right? Okay. So you can clearly see here, right? This is the circle. Okay, number 2, right? See the number 2 here. In this number 2, right? What is the rotation of number 2? The blue circle, right? That's what I'm trying to show you. Now let's talk about the blue circle thing, okay? The motion in the blue circle. Then how do you want to handle that? What is the velocity of at this position? This is like this, right? This is like this. Look at that. Number 2 is like this. What is the direction of velocity in this at this point? Left, right?
the left.
Left. So this is your BA, right? This is your BA like that. So my BA is like this. This is my BA, okay? All right. All right, so then what is the BA? How do you find BA? If this is, how do you find BA?
Omega cross R.
Yeah, thank you. Omega cross R, right? So, but the thing is, omega and R, they are perpendicular, right? Omega is coming towards me from here, okay? Out of the paper. So, and this is R. So, omega cross R, which is omega R sine theta, sine 90. You can simply say omega R because 90 is 1, right? So, what is your omega? 12. What is your, what is 12 times, what is your R? R is 0.3. So you can see this is towards the negative, right? So that's why this is negative here. Negative I. Do you agree? So let me write this down here somewhere. My BA is, how much is it, by the way?
3.6.
3.6. Thank you. 3.6, negative 3.6 I meter per second, right? That's my BA. I have my BA. Given BA, I have to find BB. Now now forget about this guy now. Let's consider this guy. This and this. Okay, let's consider AB only now. Okay, let me erase this guy. At this instant, when theta is 30, right? So, what is the circle of rotations? So I can consider this the circle here. I don't know. This is, by the way, this is instantaneous circle. See, this circle has the, you don't have the fixed center, right? See this circle made by this guy, the brown rod, the radius center is not fixed. All right, center is not fixed. So at this point, how does the rotation look like for this guy? Can I say this guy is rotating like this? See the velocity I'm talking about. Well, did I make it nice, correctly? I don't know. This is the circle I'm talking about. Okay, it's very hard because it's moving, right? It's not exactly same circle because it's rotating but not in a circle because this is moving, right? See, this guy is not, this tip is not rotating in a circle. It's rotating but not in a circle. That's the thing. But I'm trying to visualize this. At this point, I'm just talking about AB, right? At this point, your A is towards BA. BA for the rod AB. I'm talking about rod AB now, okay? Because this rod and this rod has common point A. That's why they have same velocity. So I found VA by using this. Now I claim that's the velocity of the tip of this rod A. That's what I'm trying to do. See the point? Guys, did you understand what I'm trying to do? Okay. So I found VA by using this. Then I claim that VA belongs to this now. Because that A also the part of the rod AB, right? That's why. Now I'm trying to do the bigger circle here. So in this bigger circle, so if BA is this way, then what is the rotation? Is the rotation clockwise or counterclockwise for this AB? at this instant, at the instant when theta is 30.
Counterclockwise.
Counterclockwise. Thank you. Okay. So it's counterclockwise. All right. Very good. So you have to rely on this guy to define the direction of the motion. Okay. Sorry. What should I say? The rotation, whether it is counterclockwise or clockwise. Okay. If BA was like that, like this instead, then what would be the rotation? It would be clockwise. You see the point? Okay. But my BA was like that. That's why I claim that this guy has also counterclockwise rotation at the instant theta equals 30. That's what I'm trying to claim here. Okay. All right. So with that, I think I answered your question already. So I asked the question yesterday and answered the question today. All right. So I didn't ask you, but that's okay, I guess. All right. So then how for rod B, what do you want to find? BB, right? You want to find BB, right? What is BB? What is the formula for BB? BA cross omega AB cross RBA or AB.
BA.
Excuse me?
The BA.
BA. John, can you clarify why is that?
Because you want the radius relative to B. Right?
Yeah, so see, I need to find, that's very good point. I need to find BB, right? So that's why I have BA plus this. So when I do BB minus BA, then you get what? Omega A cross R. What do you get here? BA. Because BB minus BA is what? BBA. Look at that. When you have BBA here, you have RBA here. Because BBA is BB minus BA, right? Okay. That's why if I had like this, then it would be, let me rewrite this way. If I wanted to find BA instead, I should do this. That's what I meant. See, in that case, it would be BA minus BB. Remember, when I bring this BB to the left, I will get BA minus BB, which is BAB.
That second, that should that be a cross product between VA and omega AB?
Oh, sorry.
Okay.
Thank you.
Yeah.
Okay, that makes more sense.
Oh, okay, sorry. Guys, you guys get a point. I shouldn't make mistake, right? All right, so that makes me more careful, next time. All right, so B, you understand why I got BB with respect to A, right? This is very critical, guys. It looks very easy, but when you start doing homework, then you realize, okay? This is very critical. All right, so then now I got my RB with respect to A. Now what is my frame now? Now I have the equation, right? Now based on the equation, find my frame is, where the frame is. Is the frame as A or B?
B.
The frame is, look at this, B with respect to A. That's why my frame is at A now. Okay. B with respect to A. This is always true. When you have B with respect to A, then you put the frame at A. When you have A with respect to B, you put the frame at B. Keep that in mind, okay? So now my frame is here. My frame is right here. This is my Y. This is my X. Well, it doesn't look X here, like, look like X. How about now? Looks like this is better now, okay? All right, so let's do that. All right, so let's find what is my BB. Is BB, you said it's up, right? Okay, can I write BB equals plus BB, magnitude BB, J or minus J? J, right? Because this is up, as you said earlier. Now BA is this, I already know BA. Look at that. What is my omega cross A? Is this omega? What is my omega? What is this guy? Let's say magnitude is omega AB. Then what is the direction of omega AB? K or minus K?
K, because it's coming out.
Yeah, thank you. It's K. Okay. So then what is RAB? Let's figure that out. BA, sorry. So RBA, what is RBA? My frame is here, right? So what is the length of this R, AB? Do I know? 0.6, right? So 0.6, this is my theta, right? 30. And this is my negative Y. Negative Y. All right. So let's find this guy. So what is this? 0.6. Help me. How do you split this vector into two components? That's what I'm trying to say, okay? You should be able to help me here. 0.6
Cosine 30.
I.
Yep.
Plus 0.6 sine 30 J. Did I make a mistake? Let's see who can catch it.
Didn't you say it was negative Y in that direction?
Thank you. Okay, this should be negative because this is negative Y-axis, right? So that's my RBA now. So BB, now you just plug in here now. Okay, just plug in. Let's see what happens. I have done it nicely in the slide here. Just plug in now. Okay, so then plug in this guy. So everything plugged in. So BB is BBJ, BA is this is BABK, and this is this, right? We have exactly, I just plugged in. I didn't do anything here. Now, what do? What is the next step? Next step is to compare X, first of all, you have to do the cross multiply here, right? BBJ is BBJ, this guy is this guy, omega AB, this multiplied together, then what is K times I? K times I is J, right? Then if you multiply these two guys, you get this. Similarly, you multiply this guy with this guy, which is minus. How did I get plus here? Maybe it will come somewhere. Okay, K times J there, which is minus I, right? K times J is minus I. This minus I and this minus becomes plus there. Then 0.6 times half, 0.3. Then you have omega AB. Does it make sense? Question here.
So the for the RB with respect to A, we plugged in theta equals 30.
Yes.
So this whole this VB that we're solving for, is that only at that position?
Exactly.
Okay. Right.
Okay. Yep, that's very good question. Okay, that's $1 million question. All right, very good. All right, so then we can just compare I and J, right? You don't have I on the left-hand side, just J. So just compare I and J component. Comparing I and J, what do you get? If you compare I, you get 0 equals this. If you compare J, then you get VB equals this. So from here, you can find omega B From I component, you can find omega AB. Then once you have omega AB, plug this in here. Then you can find BB. Does it make you happy? Guys, this is very important, okay? Let's go to the next subtopic. So now in this case, we already did the relative velocity, right? Now let's do the relative acceleration, right? So what is the relative velocity? Relative velocity is BAB equals this. We already know that. Now, how do you find the relative acceleration from here? Just do the time derivative, right? So do the time derivative on both sides. What do you get? This, right? Then this becomes acceleration. This guy becomes acceleration on the left. And how about on the right-hand side? Right-hand side, you do the derivative of this guy, which is d omega RAB. Then keep the omega constant and do the derivative of this guy. So when you do the derivative of this guy, you get BAB, right? dr over dt equals b. That's what I did here. Okay. So with that, I got this. Now, remember, in the case of circular motion, you have one velocity, but you have two acceleration. What I meant is you have one component of velocity. Have you guys realized that? You have one component of velocity. Velocity is always, in the tangential direction, right? Velocity is always tangential. But the acceleration is not always like that. Acceleration is both towards the center and also towards tangent. Acceleration has two components, unlike velocity. That's what I'm trying to say. So then this guy is the tangential component of acceleration. This guy, they are same thing. These are the tangential component, okay? This is how I am trying to relate. This is tangential component. Then if you plug in this guy again from here, right? Then you get this here, right? So omega cross R. And this, by the way, is the normal component. This is normal component, and this is tangential component. Because acceleration has two components. If there is rotation, velocity has one component, but acceleration has two components. One in the normal, the other one in the tangential direction. Okay, guys, does it make sense? Question here, please.
Makes sense.
Okay. Now, in the case of planar motion, what is this guy? What is this guy? Can you change this guy somehow in the case of planar motion? Okay, so I'll do this later on. Okay, I can change this to negative omega square RAB. Okay, I can do that. Okay, so how? I'll show you in a couple of minutes. So this boils down to this. All right. So then what is your acceleration then? This is your AB, right? Then what is your acceleration? Acceleration is AA equals AB plus AAB, right? Remember? The way we had velocity, BA equals BB plus BAB, right? In the same way, we have the acceleration also like that. We have this guy here. This is this guy. Now we have to put them together, meaning AA equals AB plus this guy. There, okay? This is how you find the acceleration. Now I'm going to show you a very new concept, I suppose, okay? I don't think you guys have done this before. Let me know if you have done it, okay? Have you guys done this before? Instantaneous center of zero velocity. Anybody has done this before?
No.
All right. I hope so too, because I think this is a new concept.
Can you come back one slide just for like a second?
Sure.
Okay, thank you.
All right. So then we'll be talking about the instantaneous center of zero velocity. So meaning when when our body rotates, right? Like in this case, even in this case, say this guy has instantaneous center of zero velocity. While so this I'm talking about this guy, the brown one, okay? So we consider that center keeps moving. Okay, that instantaneous center, that's why we call it instantaneous, right? So the center keep moving, center of rotation. How do you find the center of rotation? The center of rotation is found by, suppose the thing I cannot, okay, let me, suppose let me do it here, okay? Because the picture is here. Suppose this brown rod, right? This brown rod is at this position, right? How do you find the instantaneous point of rotation or center of rotation or zero velocity rather? So that can be found by doing the draw the perpendicular from these 2 points and somewhere they meet, right? Oh, here, this way. Somewhere they will meet, okay? And looks like this is a big circle. So let me do it a little nicer, okay? Let me go to the real example. I think that will be better because it has very big circle. All right. So what I say is, for any body undergoing planar motion, there always exists a point in the plane of motion at which the velocity is instantaneously zero. Okay, and we can say the rigid body is virtually rotating about that point. Okay, that's what we can do, what we can claim. Okay, so this point is called instantaneous center of zero velocity. But the thing is, this center may or may not lie on the body. Okay, this is a very nice concept, because if we locate that point, then velocity analysis can be simplified. Okay, let me show you here. Okay, this is what I was trying to do in the previous slide. So here, suppose in this case, in this is a bicycle tire, right? This is bicycle wheel, rather bicycle wheel. So for this bicycle wheel, this is the instantaneous center. Okay, so the point which touches the ground, right? There is a point on the bicycle wheel which touches the ground. That point is called instantaneous center. Okay, now how do I locate that center? Because what is the velocity of this point on the bicycle? This is like this, right? Then what is the velocity of this point here on the bike? Like this, let's say. Then, so draw the normal. Do you think this is 90 degree? Then similarly, draw the normal here. Then why do these two normal meet? There. That point is called instantaneous center. This is how you figure out the instantaneous center. Okay. So meaning, as long as you know velocity, at least two velocity. In this case, this could be this or this, or could be this or this. Any two velocity, at least two. If you know two velocity, then you can easily find instantaneous center. How? Just draw the normal and they intersect at a point. That point is instantaneous center of zero velocity. Guys? And the good thing is that, as I said earlier, the body appears to rotate about that point at that instant, okay? So That's called instantaneous center. Does it make sense? Okay. Again, I have the two velocity here. Let's say this is rotating, right? This object is rotating. So this object is rotating. Suppose at this point A, the velocity is like this. At point B, velocity is like this. Then how do you find the instantaneous center? Just draw the perpendicular here. And in this case, the instantaneous center does not lie on the body. Okay, it does not, it's outside the body. Look at this, the body is here. The instantaneous center is outside the body. But in this case, the instantaneous center happens to lie on the body. See, it's still the tire, right? I mean the wheel, okay? So it may or may not lie on the body, okay? Now, this concept is very, very useful because remember we solved the ladder problem in the previous class. We can solve the ladder problem again by using this concept now. So in that case, we did not use the instantaneous center. Okay, but here in this problem, I'm going to use instantaneous center and solve the problem. Meaning there are now you know there are two ways of doing it, right? So one of the ways is to use the concept of instantaneous center. Okay, let's see how I can use it. Okay, this is the example. So you have a point A here on the rod AB has an acceleration of this and the velocity of this. Okay, so as shown, right? At the instant as shown, meaning instant as shown, meaning this is 4, right? This is 5. Then what could this be? What is this?
3.
3.
Thank you. Okay, this is 3 meters, right? So at this instant, at this particular instant, the velocity of this A is VA, which is 6 meters per second. Acceleration is 5 meters per second squared, right at this point. Now, to solve this problem, we use the instantaneous center, okay? So what is the instantaneous center at this point? So do you know the velocity? At least two velocity of this body, Point B, what is the velocity? Point A, velocity is this way. Now draw the perpendicular. This is 90. Draw the perpendicular. This is 90. This is where they intersect, right? That is instantaneous center. Let's see how I can use that instantaneous center to determine the omega. Okay, so let's find the omega of this guy, omega AB. So it's like a circle now, right? Remember, it's like a circle now. So which one do I know? Do I know, okay, which velocity do I know? Do I know B or A? A. That's why let's make a circle with A. Sorry, let's make a circle like this. Well, does it look like this is the center of that circle? Okay, this is a hypothetical circle. Okay, now the velocity is downward. Then what is the rotation? What is the rotation here? Clockwise or counterclockwise? Help me.
Counterclockwise.
Thank you. Counterclockwise. Okay. Then what is your omega? In that circle, what is the omega? B equals omega R. B equals omega AB R. Right? Then what is your R? This is your R now. Look at that. This is your R. So how much is that? 3, right? B is how much? 6. 6 equals omega AB times 3. Then what is your omega AB? 6/3. Look at that. How cool is that? See, we had to do whole like a one page long calculation, you know, doing IJ kind of thing like that, right? Now you don't have to do IJ, just boom. You use the instantaneous center notation, notion, then you got AB right away. Okay, so then this is 2 radian per second, right? 2 radian per second. That's your angular velocity. Okay, did I make you happy so far?
Yeah, that seems a lot easier.
Okay, all right, very good. All right, so what is our goal? Our goal is the angular acceleration of the rod and the acceleration at point B at this instant. I need to find angular acceleration means alpha AB. Then acceleration means acceleration A at B. This is alpha, this is A, by the way, okay? Alpha and A, okay, they are different. We need to find alpha AB and AB. So, we don't know alpha, right? That's the thing. Looks like we have to find AB first. What do you think? Yeah, let's find AB. So how do you, so you need to find AB, right? Let's write the equation. If you want to find the AB, what is the equation? Remember from the previous AB equals AA plus AB or BA. Should I write B with
BA.
or A with respect to B? Sorry, did you say something?
Shouldn't it be a B with respect to A?
Thank you. Okay, because AB minus AA equals ABA. Remember? There. I just rearranged this guy. I got this from there. Okay, so that's why I need. So now what is your BAB? ABA, sorry, what is this guy? Do you have the note ready with you? So,
Isn't AA just 5 meters per second squared?
Yeah, that's the thing. Yeah, that's the thing, yeah. So for now, I'm going to write the equation first and formula, then I'll plug that in, okay? That's very good comment, okay? Thank you. So then what is my BA? If you have the formula from previous slide, alpha cross RBA minus omega cross RBA. Now, where do you put your coordinate system here? At A or B? Where will be your coordinate frame? Guys, help me here. I'm lost. Do you put the coordinate here or here?
Wouldn't it be A?
Thank you. It will be A because with respect to A, look at that. With respect to A, that's why it's A. All right. Now the thing is, I promise this is plus, right? So I promise that I will find this. This is equal to negative omega square RBA, right? This happens to be equal to that guy. Let me show you how. Okay. In the next slide, I have that. Okay. Let me show you here. So what is your omega cross BA? So this is your RBA, right? Because your coordinate system is here, right? Your coordinate system is here. Okay. So that's why it's coming like that. That's what I'm making here. Okay. This is what I'm making here. Then what is your omega cross RBA? What is the omega? Omega is coming out of the plane, right? Towards me. Then what is omega cross RA? Guys, this is coming towards me. Then use the hand rule. then where does the omega cross RB go? This omega is coming out of the page, right? Then you have to do the screw from here to, from there to here. You have to move the screw from here to here. Then your screw will go in like this. Remember? That's my omega cross RBA. So this is done. This guy is done. Then you have to cross it out with omega again. Again, your omega is again coming out of the plane. Do you see that? Then again, you have to omega cross this guy like this. Then what will happen? You'll get like that. Look at this. Now this guy is, if this is exactly opposite to the, so what is this guy now? This is omega cross RBA. What is the angle between these two guys? 90, right? This is omega RBA sine 90. Okay, or simply this. Then you have to cross this guy with omega again. What is the angle between these two guys? Again, 90. That's why you have omega square RBA. But what is the direction? Opposite of RBA. That's why you have negative here. Does it make sense? See, RB is this way, this guy this way. So since in the planar motion, right? This ladder is moving in a plane, XY plane. Look at this. This is the XY plane. This is not 3D. This is not 3D. This is 2D, right? XY. In the case of XY plane, XY motion, you can always write this way. This equal to that. Okay? Always. All right, let's do that then. So we have, what we have is, okay, now we have this. So as you said earlier, Tyler, my AA is negative 5, right? My XY is here now. This is negative Y, this is X.
Yep.
So A is minus 5, right? You can see here it's coming down. That's why minus 5J. What is my AB? I don't know the magnitude, but I know the direction, right? AB is towards the right. Okay. That's why AB is I, AB times I. Okay. Now let's use the thing. Let's use this formula. We know this formula, right? Now we change this guy to this guy already. So like here. Now let's plug in now. ABI. AB is ABI from here. AA is minus 5J from here. Then alpha, what is the direction of alpha? Look, this rotation is what? Clockwise or counterclockwise? Counterclockwise. In the case of counterclockwise, your omega is increasing, your alpha is what? Up. That's why your alpha is K, not negative K. Okay, this is done. Then RBA, let's figure out RBA. How do you find RBA? My coordinate system is here, right? Here. So what is RBA? This is, how do you find that? Guys, help me. This guy. So RBA. Can I say 3I and negative 4J? Guys, RBA is 3I negative 4J. That's what I did here. Then similar negative omega square, which is omega is 2. We already found it in the previous slide, 2 square. Then RBA, again, the same thing. Now you got the idea already, so I know. So just, just simplify it and compare the coefficient. That's all, right? That's what we need to do now. All right. So then here, this guy is this guy. This is done. This guy is this guy. How about here? What did I do here? Alpha cross with this guy. K times I is what? J, right? Then 3 times alpha, 3 alpha. Then K times J is what? Negative I. That's what I have here. This guy comes here. Then 4 alpha. That's it. So I did that. Then here I have 4 times 3, 12, negative, and this is plus 4 times 4, 16. There. Now I just have to compare. Now I can, you know, collect similar terms here. This guy collected with this guy comes here, and this guy, and this guy. So which is 3, negative 5, and 16, 11, and 3 alpha there. So I have this equation here. On the left hand side, I have ABI. Does it make sense? Okay, so what do you do now? You can solve this equation now, comparing I and J coefficient, right? So I have this from previous slide. Now I can solve for I and J. I meaning, what do you get for the I? AB equals 4 alpha minus 12, right? See, this guy, this. So which is exactly this. Then you have J component is 0 on the left-hand side. So that's why 0 here. Then we have this guy here. How many equations? How many unknown? 2 equations, 2 unknown. Ta-da. From here, you can find alpha. Then plug this in here. You can find AB. So we found both of them. We found alpha. We found AB. Okay, guys, if you have question, I'm ready for the question. If not, I'm done.
Makes sense.